Hello. In this video, we're going to be looking at binary clocks. So what are binary clocks? Well, as you can see from the video currently playing, we have a set of clocks that count in binary. So just like a regular clock counts from 0 to 60 seconds, and then from 0 to 12 hours, binary clocks simply count from 0 to 1. And I think this is a really nice visualization of how counting in binary works. I'm pretty sure most people have seen examples of counts in binary. Perhaps you've even seen some animations in which it has something similar to the top row. So we count binary numbers, so it goes from 0 to 1, 0 to 1, 0 to 1. Every time there's a 1 here that transitions to 0, the next bit is incremented, and likewise every time there's a 1 here, and the bit is incremented, it increments the next bit, etc, etc. And that goes on indefinitely, or in this particular case, for as long as the binary number exists within its given bit depth. So if you look here, once all the numbers are 1, the next tick of the lowest binary clock pushes all the numbers back to 0, which is called an overflow. You can also imagine this as a smaller clock on the right that's ticking twice as fast. And if you wanted to extend it, there would be another clock on the left ticking half as fast as the one to its immediate right. And so this is quite a nice visualization of how actual binary counting can be thought of. So binary counting can just be thought of every second we change the value here. Every 2 seconds we change the value here. Every 4 seconds, 8 seconds, etc, etc. And this also shows you another way of thinking about clocks, is that you don't necessarily need to know what each clock is doing for the next clock to actually be able to tick. It's simply each clock is related by a certain phase relationship and a frequency relationship. So the phase relationship is that at the beginning, all the clocks have the same phase, so all the hands point in one particular direction. And then the frequency relationship is that however fast the lowest clock ticks, the next clock to its left ticks half as fast. So this one here is ticking at 1 Hz, so it makes a complete revolution during 2 seconds. Look at this, 1, 2. The clock to the left of it makes 1 complete revolution every 4 seconds. 1, 2, 3, 4. The clock to the left of this makes 1 complete revolution every 8 seconds. 1, 2, 3, 4, 5, 6, 7, 8. And again, the clock to the left of that makes 1 complete revolution every 16 ticks, etc, etc. So much like binary, in order to work out binary number, all you have to do is do 2 to the power 0 times this bit, 2 to the power 1 times this bit, 2 to the power 3 times this bit, etc, etc. You can think of it as a bunch of clocks, all moving with a relationship of half the speed. And so in this video, we're going to be making this little animation using Python. Before we go on, I want to show you one more example of what we can do with a normal clock. And so for example, a normal clock is something like this. The lower hand, so the second hand, goes round once every 60 seconds. In this case, I've actually sped the video up because it would take 60 seconds for the hand to rotate. But imagine once every 60 seconds, this hand rotates. And then for the minute hands, once every 60 minutes, this hand completes full rotation. And then for the hours, again, twice every day, so once every 12 hours, the hand makes complete revolution. So again, there's a relationship between the phase and frequency of these clocks. So the phase relationship was that each one of these clocks started off where all the hands pointed at the top. And then the frequency relationship is that this one ticks round at 1 over 60 Hertz. This one ticks round at 1 over 3600 Hertz, and this one ticks round at whatever 1/24 of 1 over 3600 is. So I think this is a really nice way of visualizing this. And so how are we actually going to do this? So we'll be using Python, but we're also going to be doing mainly object-oriented programming. So what does that mean? It means that we have to think of things as different objects. So this is actually a deconstruction of a clock. We have the second hand, the minute hand, and the hour hand. So we've deconstructed the clock. And when you think about it, what we can see here is we have several things that are similarly related. We have 3 clocks on the bottom, so we can think of each clock as an object in itself. Each clock object would have a particular frequency and a particular start point. So there's no reason why this can't be object-orientatedly programmed. because the clock object itself is an object. Likewise, the numbers at the top are simply a number that is moduloed by a particular value associated with this clock. Or an even better way of putting that is that this number itself is moduloed by a value that increases with frequency. All we have to do is increment this timer here by 1 every second, and then do the modulo division 60. Likewise, this here is incremented once per minute. Then the modulo of that is done with 60. Likewise, for the hour hand, that's incremented once every hour. And then it's moduloed with the number 12 because it's a 12-hour clock. And then quite simply, all we have to do is put these three, we'll call these bit, or all these number classes at the top together in a row. And then likewise on the bottom, all we have to do is put these three different clock objects next to each other. So that's how we're going to be doing it. Let's open up our trusted Spider. So I'm a big fan of Spider because it has a nice variable explorer, and it's quite good if you've just downloaded Python for the first time through the Anaconda library, or perhaps you're a data scientist or an undergraduate. And so the first thing we need to do is import things that we're going to need. And these are all the imports we need. So NumPy will be our numerical Python, so things we're doing with numbers. Matplotlib PyPlot is what we're going to use for plotting, along with the function animation for Matplotlib animation. I'll create our animation. Also imported matplotlib MPL. Typically you don't normally do this because it's quite a heavy import, but since it's just a simple animation, I'm going to allow it. And then we also import grid spec because that will allow us to put our plots on a grid. So the first thing we need to do is think about what are our objects. So we're going to need a clock object, which we do in Python by doing classes. So we do a clock object, and we also need another object, and I'm going to call this object, we'll call it it's basically the display object for the clock. It's sort of digital display, so it has a modulus associated with it. It's more like it's like a timed modulus number. Mod. We'll call it a timed modulus number, why not? So the first thing we need to do is we need to think, what do we need for our clock? Well, when I showed the video earlier, see here, so we've got several things. So the first thing I'm going to do is I want to make sure that the colours are right on this plot. And I also want to make it easy to change the colours, because at the minute it's a black background with white text and white clocks with a blue hand. What was if, say, we wanted to see what happens when we change the colour? Maybe make a white background with black text for, say, Wikipedia or something. I want to make that easy. At the top of this class, I'm going to create class level variables. This will be shared between all instances of the class. So it exists outside the local scope of the class. It exists in the class itself. And I put here that background color, which defaults to black, text color, which is white, clock color, which is white, and the hand color, which is blue. And then when you come to object-oriented programming in Python, you need an initializer function. So this is your constructor. This is called when you first create an instance of the class. And we just think, what do each of these clocks need? Well, the first thing you'll need is access to itself. So be able to assign variables to itself and use variables from itself. So this is that particular instance of the class. It definitely needs a frequency, because that determines how quickly the clock ticks. We're also going to give it an axis object, so we'll create a plot with space for all the different clocks and numbers, and we'll tell it, here's your space, here's where you're plotting. I'm also going to give it a base, because I showed an example of a real clock, which is base 60 or base 12, depending on which hand you're using. But also it'd be quite good to have a different base for the binary clocks. So it would be good if we could dynamically change the base. And that also allows us to play with this, because if we make it so that we can handle base 2 and base 12 or base 60, handle any base, we can see what happens. Ooh, what happens if we have a base 8 clock, for example? So things like this are always quite interesting. And then I'll also have a scale, because I might want to scale the text on the clock, but we'll see about that later. We'll see if we decide that. So what I'm going to do now is I'm going to make sure that the instance of the class has access to all these variables that are given to it during the construction. So that's what I've done here. I've basically made copies inside the class itself, so local copies inside the class instance of the values that are given to the constructor. So these are now available to all functions inside this class. And then we'll do a private method here called initialize. So I've used a double underscore just so it gets obfuscated, and so it can't be accidentally called again, because I only want this ever called once. And the reason I've done this is because I don't want it littering up the initialization class. You want to keep that relatively clean. So here I'm going to do everything that I want to do inside the class. So I definitely need a time variable. I want the clock to be able to keep track of time, because then that will determine where the hand is. Okay, I'll come back and we'll do some more stuff with the axes later on. But basically the first thing we're going to need is to add a circle. So clock is enclosed in a circle. And we know that the axis object will be a matplotlib axis object. So we'll give it a patch. So patch is just basically a shape. Then we're going to pull up the circle object from matplotlib. And then it is an xy, 0.5, 0.5. And I'll be doing this relative to the size of the axis. So everything is relative from 0 to 1, 0 to 1. It doesn't matter what the actual data axes are. This is the axis of the plot. So think of these as a relative axis. Go ahead and give it a radius of 0.49, so that just stops it clipping at the edge. Fill equals false, so we don't want the circle to be filled. We'll do the trans axes for the transform, so that's making sure it obeys the 0 to 1 as the actual plot extents. And here's where our colours come in. So we say the colour of that circle line is going to be the colour determined in this class variable here. So clock is white. And then we need to add the numbers. So the numbers should be quite easy. For I in range self.base. So for a 12-hour clock it will go from 0 to 11. For a 2-bit clock it will go from 0 to 1. Then we want to add a text object. Again, we'll do this relative to the axis object. So we want it to be in the middle. Then we're going to offset it by some trigonometric functions. So it needs to go around in a circle. So these ways to do that. Do numpy.cos. I'll just copy something over now because it'll be simpler. So you see here that our x coordinate starts at the middle at 0.5, has a radius of 0.4, and then it starts off cos with numpy.pi over 2, so that means it starts off at the top, not on the right. So typically the cosine function starts off with a magnitude of 1 and then goes round to -1 and then back to 1, so that's starting off along the x-axis, where sine starts off 0 on the y-axis. We want to just offset that by 90 degrees. Then from minus sign here, so it ticks in the clockwise direction, because the standard implementation of cosine and sine in terms of x and y rotate in the counterclockwise direction. And what's beautiful about this is we can just go ahead, copy that, and just change that to sine. So that should equally space our numbers on the inside of our circle. We need to give it some other things there, however. So we need to tell it what the actual string is. So the string is just going to be the numbers, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11 for a 12-hour clock. Tell it to align to the center for both the horizontal and vertical, and that's because it's going to be quite difficult to change the alignment based on where it is around the clock. And that's also one of the reasons why we chose a 0.4 as our radius. And it also means that we're going to have to be a bit careful with our scaling, but luckily we've got a scale variable. Color is another simple one. We can simply say colors of the text, which we said here was going to be white. And again, all we have to do is change this one thing up here, and it will change all the required colors. Font size is the one that's quite important. I found that when doing this, so you can do it by scale, so it will scale with the font size. But I found quite a nice thing to do is to do the following. So it's scaled with this scale of that value here, but in general, if there are too many numbers, so when you do it if you did like a base 60 clock or something quite extreme, the numbers end up too big. So we need a function where below some value, it's basically the scale, and then above some base value, it needs reducing even further. So I wouldn't worry too much about that unless you're doing crazy bases for your clocks. And then again, we need to tell it that the transform is the trans axes. And then we need to go ahead and do an arrow. And we want to keep track of this arrow, because this arrow is something that's going to move. So we'll give it 0.5 again, so it starts off at 0.5, x and y. It goes 0 in the x and 0.4 in the y, so that's the extent, because remember the arrow starts at the top. Give it a nice width, 0.05. Make sure the arrow has a head. Make that bigger than the body. And then there's an important variable here, length includes head. That's important because that will make sure that the arrow is guaranteed to be 0.4 long. If we don't do that, then it's going to be 0.4 plus whatever ratio of this head width to width is, which is not what we want. We've already have a color variable for the hand of the clock. Remember at the top here, we said hand. And then the last thing to do, let's give it a line width, something equals 1. Then again, making sure we have our transaxes as our axis. Go ahead, neaten that up. So we get quite a nice looking class. The next thing we're going to want to do is to make sure that we can actually update this clock. I suggest we have a function called update. Def update. So this will basically say the clock is ready to update, and because it has a handle to the axis object itself, we should be changing the state of the artists. All I have to do in the update function is do two things. The first one is find the coordinate, and then if you look here, all we're doing is saying set self.arrow.setTransform. So we're giving it a transformation. Transformation is going to be relative to the data axis, which we've transformed here. We're then telling it to, I don't think we need that actually. I'm not sure if we actually need this, but I'll roll with it. That's how it was done before. This might actually be relative to some plot things later on, but we'll see. We give it an affine 2D transformation, and the affine 2D transformation we're giving it is rotate around. We rotate around X and Y, so I've splatted X and Y out of here. So X and Y has been splatted out, and then we rotate by minus, because remember that it has to go clockwise. Minus, and then here we have frequency times time. Because remember, we're going to change only the frequency of these objects. So if you look here, this clock object does not know what position it's in. So if it was a binary clock, it doesn't know what bit it is, because that's all taken care of by just selecting the correct frequency, which I think is really nice. We need some way of incrementing the clock, so it's not just good enough to update it. Let's do an increment function, and let's say the default behavior is to not update it. But we'll be doing that anyway. It's just good to have these functionalities available in the class. You don't have to come back and write a class, because someone might want to increment without updating, because then there'd be no way. If by doing this you at least have the ability to do so. And also by default, the increment literally just increments the time, it doesn't update, so it's true to its original name. And if update, self.update. So if we had a clock object now, then every time we called increment and gave it an increment to increment with, it would update the plots. So let's just go ahead and do that. So before we do our tmodnum, go ahead and create some plots. The plots is quite easy. Do something here. So we're going to say fig equals plot.figure. We're going to give it a constrained layout. Constrained layout, give it a figure size and a DPI. Let's create a custom figure size. Do a manual one for now, but we're going to do this smart later on. So do fig size equals, let's do 12 inches by 6. No, 12 inches by 4. That will be our default figure size there. And DPI, just make sure that we don't get any aliasing effects from having a mismatched default DPI in the plot.figure, which I believe is 100. This is your screen, so I particularly would have little white lines appearing so that this not to be included. And then let's quickly do an animation just to check it's working. We don't need it to be accurate right now. So we create an animation function. It needs a figure, which we've got, fig here. It needs a function, so def, call it plot update. That will get a frame number, which is useful for, say, saving it. That's for now. Interval will be 1000 divided by FPS, which we will define here. So plot FPS, plot vars, FPS equals 60. Number of frames, that will be an interesting one. Let's do 100 for now, but that's going to be dynamically chosen later on. Blitting true, repeat false. So when blitting is enabled, it needs a list of everything that has changed. So if we go back to our clock instance, we can do something really simple. We can get a list of all the updatables. So get updatables. Oh, let's do camel case. Get updatables. And we just need to return everything that would update on the plot. So that's really easy because it's basically just the arrow. So let's return the arrow. That's the thing that updates on the clock object. So let's return. Let's just create one clock. Clock equals clock. Give it a frequency of 1 Hertz. We need to give an axis. We need to give it a base and a scale. So base can be, let's do a 12-hour clock, 12-hand clock. In fact, let's do 1/12. 1/60 of a second. Let's write that down for viewers at home. Axis equals base equals scale equals 1. So I've created a clock. And for the axis, so we'll go ahead and create a plot for this. The first thing we need to do is grid it, so we need a grid spec. Let's just give it 2 rows for now, 2 columns. And then let's create an axis from this. Let's say equals fig.add subplot. We run it for the grid, and let's actually do grid. Let's put it in the top left just for now. Remember, we just want to see if this works. This isn't the final animation by a long shot. Plot initialize. You know what? We don't need that, I don't think. Okay, and then what we want is let's just do clock dot get updatables, and then let's do clock dot increment. Let's increment it by 1 over the FPS, so it's basically real time, assuming that this plot can go at the FPS. Go ahead and plot that. See, that's not worked. And that should easily be fixed, because remember I said the default behavior for increment should not be to update, because it's an increment function, so updating should be optional. So we just need to make sure that we put update equals true. Go ahead and plot that, and as we can see, this arrow should rotate around the point 0.5, 0.5 once every 60 seconds. Go ahead and do that. It does indeed look like it's working. The last thing to do in this video is we need to do some things. So we'll take the axis off, so we don't want the axis being drawn, we don't want the X and Y ticks. We do want an aspect ratio of 1, so we need the clock to be round, not elliptical, and I'd also like the background to be black. Quite easily do, once we create the figure here, we can do fig.patch.set base color. And again, let's just pull it straight from the clock class, so clock.colors. Go ahead and put that. And there we go, we see we get our nice little clock object. A bit of an issue with our numbers, but that's no problem because we can quite easily change the scale. So where's our clock object scale? Let's put 22, see what happens. Oh, there we are. It's a clock object. It's exactly what we wanted. And it is indeed ticking round at the right rate. So that's where I'll leave this video. In the next video, what we'll go and do is we'll go ahead and add all the clocks and all the bits to the top, and then we'll start playing with it. So thanks a lot for watching. Hope you found this interesting, and stay tuned for part 2.